video is to give an introduction to the concept of intelligent agent as well as present the Open AEA framework. The most general definition of an agent is anything that makes decisions in order to execute actions towards the completion of a given objective. So an agent perceives its environment through sensors and it actuates on that environment through actuators, with the goal of maximizing or approaching as much as possible to the predefined goal. This environment may contain other agents, and of course, they can all interact between them. Agents can be classified according to the degree of perceived intelligence and capabilities. The most basic type of agents are simple reflex agents. This kind of agents observe the environment and based on that observation, they execute some action. For example, think of a thermostat. A thermostat will turn on the heating system when the temperature reaches a certain threshold. Model-based reflex agents have some sort of internal data structure that represents how they perceive the environment. They take decisions based on the measurement that they execute on the environment and on this internal representation of the environment. Goal-based agents have, in addition to that representation of the environment, they also have some sort of indication if the environment is in a desirable position or not. Utility-based agents is a refinement of this kind of agents, of goal-based agents, so that they use the concept of utility function, which gives a fine-grained description on how desirable the environment is. Finally, the most complex kind of agents are learning agents. These kind of agents are able to operate on unknown environments and gain knowledge progressively in order to approach to their objective. It is out of the scope of this presentation to give details of all these kind of agents. The goal of this first half of the course is to give you an overview of the Open AEA framework so that you have the necessary tools in order to develop your own autonomous economic agent. So first of all, what is an autonomous economic agent? An autonomous economic agent, or AEA, is an intelligent agent acting on an owner's behalf with limited or no interference and whose goal is to generate economic value for its owner. The main features of the Open AEA framework are: first, it is modular. That means that the framework allows you to define a number of packages or extensions so that you can tailor-make your agent according to your needs. It is open source, it has native blockchain capabilities, and what's important is that a single agent can be connected to multiple blockchains at the same time. It allows the development of both private single-agent services that can work for yourself or public multi-agent systems. Multi-agent system services will be the main focus of the second part of the course. Also, the framework has inbuilt agent-to-agent communication. This allows agents to communicate, and what's important is that agents can benefit from the knowledge of other agents so that they can increase their knowledge in order to achieve their goals faster. The Open AEA is a fork of the original AEA framework. So, in order to offer like a small comparison on what traditional web development differs on agent development, on traditional web development, what we are actually implementing is how to serve the user requests. So this is usually based on private and closed source repositories. So there's a centralization on the hosting deployment and the ownership and control of the service. And the focus, the main effort, is to create some sort of user experience or user interface so that users can interact with the business logic which is on the back end of the systems. On the other hand, when it comes to agent development, what we are doing is to implement the user desires or the users what the users want to achieve as an agent. So in this case, the focus is put on creating applications which automate the workflow for the user. It's usually based on public and open source repositories. And as I have just said, agents implement what the user would do. And agents are viewed as external operations from the blockchains. So that is, they are seen as blockchain users. So agents are not in fact L2s users as they don't scale transaction execution, and they rather implement the application specific logic on blockchains. And what's important is that services and apps are owned and controlled by a group of entities. So this brings the decentralization of the services. Services are not owned by a single entity. The Open AEA framework defines a number of components that every agent has internally. It is important to notice that there are two kinds of components. On one hand, we have the core components, which are those which are highlighted in red. Those components are common for all the agents. In addition to that, the framework also defines a set of extensions that are the components that the developer is able to produce in order to make the agent tailor for their needs. Core components are in charge of executing common tasks, such as handle message passing or executing the actual loop of the agent. On the other hand, packages define custom components that can be developed by anyone. Let's start by the first component, which are the envelopes. Envelopes are simply wrappers for messages. Envelopes are used to communicate between different components within an agent, but they are also used to communicate between different agents. An envelope defines 6 fields, namely originator, destination, protocol ID, the message itself, and some optional field which is called context. Messages within the envelope must be specified according to a protocol that we will review next. So protocols are an extension. That means that it is a component that can be developed according to the particular needs of a given application. So a protocol is a component that defines the rules for communication between agents or between components. So they must define what are the messages that compose the protocol, what is the serialization of those messages, and they also need to define the dialogues. The dialogues are essentially the rules over messages sequences. For example, I cannot receive a response if I haven't sent a request. So protocol messages are wrapped in envelopes and they are sent to other agents via connections that we will review next. As it is an extension, the developer can provide protocols according to their needs. However, the library comes with a predefined number of protocols, like HTTP, Ledger, Contract, and some others. So it is very usual that the developer has usually enough with those protocols, and there's usually no need to develop their own protocols. However, there's a protocol guide that will provide some help if the developer needs to build a custom protocol. There's also a protocol generator that it will be helpful in the process of creating a new protocol. Just to take a brief look at how a protocol specification looks like, here we have an example for the HTTP protocol. So you can see that the specification defines the request and response messages for this protocol. So the next component that we are going to review are the connections. Connections is an extension, so this means that the developer can develop their own connections. So typically we will have one connection per protocol defined on an agent. So a connection is essentially the component that wraps an SDK or API and provides the interface to network, ledgers, or other services. So the connection is the component responsible of translating between the external message format and the internal message format for the agent. So connections are managed by another component which is called the multiplexer. So as I just said on the previous slide, connections can be added as packages because they are part of the extensible part of the library. So again, just to take an example on how a connection specification looks like, here you have an example of the YAML that defines a connection for HTTP server. As you can see, there are a number of parameters that configure the particularities of this connection, such as, for example, the host address, the port, or the SSL keys. So the next component is the multiplexer, which is also a core component. So the multiplexer essentially is a component that manages the connections for the agent. So the multiplexer maintains an inbox and an outbox, where the messages incoming to a connection are placed in the inbox, and the messages that are going to be output to a certain connection are placed by the agent in the outbox. So the multiplexer is just a component that manages this stack of messages where the remaining components of an agent can access to either read messages or post messages. So the next component that we are discussing are the skills. Skills, again, it's an extension, so this means that the developer can develop as many skills as they want. So skill is the key component or the most important component of the framework. So skills are one of the key components of the library because skills represent the agent knowledge. So each skill represents a self-contained capability that represents such knowledge. So they implement the business logic to deliver economic value to the agent. An agent can have skills either defined from the beginning, or they can dynamically take skills on board in order to expand their knowledge. So for example, you can think of a skill as some sort of functionality that scrapes the web in order to get some sort of information. So for example, some sort of market valuations. And you can have another skill that is in charge of executing some sort of investment strategy. Skills will be discussed in detail in another video, but for now it is enough to know that skills contain a number of components. So most notably, skill contains handlers, which implement the reactive actions to external events, behaviors, which implements the proactive actions of the agent, and model, which are custom data objects, which are accessible via the skill context. The next component of the library are contracts, which are also part of the extensions. So the contract object of the library is simply a wrapper for smart contracts on the centralized ledger. So they provide a wrapper around the API or AVI, and they implement a translation between the framework messages and the implementation specifics of that AVI. So the contracts that can be wrapped can be either third-party smart contracts or can be own smart contracts. Contracts need to implement 4 types of methods. First, a method to create a smart contract deployment transaction. Next, methods to create transactions to modify the state on the deployed smart contract. Also, methods to create contract calls to execute static methods on the deployed smart contract. And finally, methods to query the state of the deployed smart contract. The next component of the library is the decision maker. The decision maker is a wallet manager plus the economic brain of the AI. It defines a set of preferences and goals according to the user needs. It is responsible for the AEA, crypto economic security and goal management. And most importantly, it is the only component with access to the wallet's private keys. So, in the simplest form, the decision maker can be thought as a wallet with a handle that reacts to messages that receives from skills. The wallet contains the private and public key pairs used by the agent. Again, remember that skills do not have access to the wallet, only the decision maker does. So, if some skill needs to execute some sort of operation that requires to use one of the keys held by the agent, it has to do so through the decision maker. Each agent has two sets of private keys, which are configured on the agent configuration file. So private keys, which identify the ledger-specific keys, and private keys using the connections. So keys cannot be reused by different agents. So using the same key across different agents will lead to some sort of failure modes and security issues. There is also the notion of identity. So the identity is just an abstraction that represents the particular agent. It contains the agent addresses as well as the name. The identity can be accessed in a skill via a component which is called the agent context. So finally, it remains to review the agent loop, which is, let's say, the controller of the whole agent. The agent loop is a component that orchestrates the life cycle of the agent. It executes continuously the following tasks. First, it calls the act function of all the registered behaviors. Remember that the behaviors are part of skills. Second, it grabs all the envelopes waiting in the inbox of the multiplexer, and it calls the handle function of the corresponding handler. Finally, it dispatches the internal messages from the decision maker to the handler in the relevant skill. So to wrap up, this is the agent architecture again. So let's look at how a message will transit through the agent components. So imagine, for example, that we are receiving a response from an HTTP server. So this message will arrive at this component, at the connection. The connection will enforce that this message and the dialogue in which this message is in follows the rule defined by the corresponding protocol. It will then be responsible of translating this message into the appropriate format, and it will be in charge of placing it in an envelope. This envelope will be transferred to this inbox here, and the agent loop will read this inbox when it arrives at this step here, and it will route this message to the corresponding skill. Within the skill, the handler will be in charge of processing this message. On the other hand, a behavior which is in charge of executing the proactive behavior of the skill, whenever he decides it's the proper time to send a message, it will place this message in the outbox, and the HTTP connection component will be in charge of sending this response back to the server. So again, there are like 4 kind of components that can be developed as extensions, but the library provides a number of components, such as, for example, the library provides different connections, different protocols. So this means that the typical life cycle of an agent will be mostly devoted in developing the relevant skills for the agent that we are interested in. We will review a little bit more in detail agent skills, which are the core components when it comes to the extensibility of agent capabilities. Remember that from the point of view of the library, skills are extensions. This means that developers can either reuse already existing skills for their agents, or they can program their own skills according to their business needs. Remember that skills are self-contained capabilities that represent agent knowledge. Skills contain a number of subcomponents such as handlers, behaviors, and models. They also have access to a skill context, which in turn provides access to the agent context. We will review these subcomponents next. Handlers implement reactive operations for a skill, that is, operations that respond to external inputs. Each skill can have 0, 1, or more handler objects. And there's a one-to-one correspondence between handlers and the protocols that are registered in an agent. The handle method is the main method in a handler object, and it implements its functionality. If an agent understands a certain protocol, that is, if the protocol is registered for an agent, then envelopes can reference it, that is, the agent can receive envelopes referencing that protocol, and such envelopes will be sent to the corresponding handler. Here on the left, we have the organization of the Open AEA repository. If we browse until we find the echo skill, we can see that it's composed of a number of files. The echo skill simply receives as input a message, and it outputs the same message. If we open the file handlers.py, we can see that the main class here inherits from the parent class handler. This class defines as an abstract method the method handler, which must be implemented. Inside this method, we can see that it processes the message type at this line here, and then it handles the bytes. The method that handles the byte of the message is a private method. And as you can see here, it generates a reply, which is simply sets as content the same message that it received. Finally, it outputs this message to the output box. The next important component within a skill are the behaviors. Behaviors implement the proactive actions of the skill, that is, actions that doesn't require any external input to be triggered. A skill can have 0, 1, or more behaviors. There are a number of abstract-based classes implementing different types of simple and composite behaviors. We will review this in the next slide. The act method is the main method of the behavior where the action must be implemented. These are some examples of the base classes that a behavior can have. For example, a cyclic behavior is executed until the agent is stopped, and this class has the method number of executions so that you can check how many times it has been executed. The one-shot behavior will be executed only once, and the ticker behavior will be executed periodically within an interval. The sequence behavior is a composite behavior which executes sub-behaviors in order. There are other kinds of behaviors, and you can explore them in the library. If we browse the echo skill again and we open the behaviors.py, we can see that this skill contains one behavior, which is the echo behavior. This behavior is a ticker behavior. That means that it will be executed periodically at a tick interval. But in this case, we are just simply logging some information on the output. This is because this is a very simple behavior and it's not doing any action. In Module 2, we will review behaviors that execute more complex actions. Each skill has a skill context object which contains state preferences and configuration options. This information is local to that skill. It is accessible to the handlers, behaviors, and models of the skill. Also, the skill context has a link to the agent context, which in turn provides access to the agent-specific information like the public key, and the address of the agent. In this case, it's read access only. It also provides access to the outbox. So that means that it's possible to grab the context from any of those objects and has access to the objects in other parts of the skill. We have already seen an example of the skill context. If we go to the echo skill again, and we open the file handlers.py, we can see that the echo handler, which implements the handlerBytes method, is accessing the skill context at this point. Then it's calling the outbox object, and then it's calling the method putMessage. The outbox object is actually an object from the agent context. However, for convenience, the skill context provides some wrapper methods to the agent context. Here, you can also see an example of the usage of the skill context. Another important component of a skill are the models. A model represents an abstraction for some data object related to the business logic of the application. A model here plays exactly the same role as a model in the model view controller paradigm. Skills may contain 0, 1, or more models, and all model objects inherit from the model abstract base class. The echo skill doesn't have any model because it's a very simple skill, but models will be used in Module 2 when we discuss the concept of synchronized data across multiple agents. The final component that we are discussing are tasks. Tasks encapsulate background work internal to the agent. 0, 1, or more tasks can be defined. The difference between tasks and handlers, behaviors, and models is that tasks are not part of a skill, but they are declared from a skill if a packaging approach for the agent creation is used. The main file that defines the skill is the skill.yaml file. In this file, we have a reference to the files that compose the skill, and also a reference to the internal components of the skill, that is, protocols, behaviors, handlers, etc. In this file, we can also define arguments or parameters either for the skill itself or for some of their internal components. For example, if we see here, the skill contains a behavior called echo behavior, which is a tick behavior, and this behavior requires to specify the argument tick interval, which is how often the behavior will be executed. Let's recap again how the framework works. The framework is in charge of calling the various components. The behaviors are called based on their tick rate, and handlers are called when a message that they are able to process arrives. Connections run continuously, and the multiplexer processes incoming and outgoing messages. The agent loop, which can be considered as the main controller here, is in charge of calling the act and the handler envelope methods on skills, and it also calls the handler envelope method on the decision maker. Finally, the task loop executes the available tasks. We have reviewed what is an intelligent agent and what is an autonomous economic agent. We have given an overview of the Open AEA framework. Especially, we have focused on the internal components of an AEA. We have also given an overview of how the AEA message-based communication works. And we have also taken a look at how the AEA's internal components interact between them. We hope that this video has given you an overview on what is an intelligent agent and what can you do with the Open AEA framework.